Hi everyone, this is Mr. Zirkle and this video discusses Earth's atmosphere. Earth is the only planet in the solar system with an atmosphere that can sustain life. The blanket of gases not only contains the air that we breathe, but it also protects us from the blasts of heat and radiation emanating from the sun. It warms the planet by day and it cools it at night. Earth's atmosphere is relatively thin, only about 300 miles. Now, you might say that seems pretty thick, but keep in mind that the diameter of the Earth is about 8,000 miles. Even though our atmosphere is about 300 miles thick, most of it, by volume, is within 10 miles of the surface. Atmospheric density and pressure decrease as you move upward. Our atmosphere is divided into 5 main layers: the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. The atmosphere thins out in each higher layer until the gases dissipate in space. There is no distinct boundary between the atmosphere and space, but an imaginary line about 62 miles above the surface, called the Kármán line, is usually where scientists say the atmosphere meets outer space. Earth's atmospheric layers are based on temperature gradients. You can see this in the diagram that as you move upward through the atmosphere, the temperature alternates between cooling and warming. For example, in the bottom layer, the troposphere, the temperature decreases as you move upward. Then, in the stratosphere, right above it, temperature begins to warm as you increase in height. I want you to take a moment and do a few things for me. Pause the video, fill in the 5 layers of the atmosphere on your diagram, and also draw the temperature line as you see it, preferably in some different color. All right, let's go through the layers and discuss a little bit about each one. The troposphere is the layer closest to Earth's surface. It's the layer in which we live, and it's the layer in which weather occurs. Nearly all of the water vapor and dust in the atmosphere are in this layer, and that's why clouds are found here. It's between 4 and 12 miles thick, and it contains half of Earth's atmosphere. Air is warmer near the ground, and it gets colder the higher up you go. The stratosphere is the second layer. It starts above the troposphere and it ends about 31 miles above the ground. Ozone is abundant here, and it heats the atmosphere. That's why temperature increases in this layer. The ozone is also helpful to us because it absorbs harmful radiation from the sun. Life as we know it wouldn't exist without this layer. The air here is very dry, and it's about 1,000 times thinner here than it is at sea level. Because of that, it's where jet aircraft and weather balloons fly. The mesosphere starts at 31 miles and extends to about 53 miles high. The top of the mesosphere, called the mesopause, is the coldest part of Earth's atmosphere, with temperature averaging about minus 130 degrees Fahrenheit. This layer is hard to study. Jets and balloons don't go high enough to study it, and satellites and space shuttles orbit too high. Scientists do know, though, that this layer protects us from meteors by causing them to burn up. The thermosphere extends from about 56 miles to between 310 and 620 miles. Temperatures can get up to 2,700 degrees Fahrenheit at this altitude. The thermosphere is considered part of Earth's atmosphere, but air density is so low that most of this layer is what would normally be thought of as outer space. In fact, this is where the space shuttles flew, and it's where the International Space Station orbits Earth. This is also the layer where auroras occur. Charged particles from space collide with atoms and molecules in the thermosphere, exciting them into higher states of energy. The atoms shed this excess energy by emitting photons of light, which we see as the colorful aurora borealis and aurora australis. The exosphere, the highest layer, is extremely thin, and it's where the atmosphere merges into outer space. It's composed of very widely dispersed particles of hydrogen and helium. Earth's atmosphere is a mixture of different types of gases, each with its properties and percentages. If we look at dry air, nitrogen accounts for 78% of all gas in the atmosphere. Oxygen accounts for 21%, while argon accounts for just under 1%. Though it has a large effect on our atmosphere, carbon dioxide accounts for only about 33 hundredths of a percent. Together, these four gases account for 99.998% of all gases in dry air. Nitrogen and oxygen, the two most abundant gases, have no effect on our weather. Oxygen, as you know, is produced by plants during photosynthesis, and it's important because humans and other animals need it to breathe. It's also a necessary component in the combustion process. If we want something to burn, we have to have oxygen. Argon is what we call an inert gas, meaning it doesn't react with other gases. It too has no effect on the weather. What does have an effect on our weather is carbon dioxide. Carbon dioxide absorbs energy and heats up our atmosphere. This natural process is important. Without it, Earth's average temperature would be around 0 degrees Fahrenheit. However, the addition of too much carbon dioxide is now our problem. Our atmosphere is retaining more heat than it should, causing the average global temperature to increase. One last thing you should keep in mind about carbon dioxide is that it is taken out of the atmosphere during photosynthesis. When fuels are burned, carbon dioxide is released back into the atmosphere. There are some other things that are in our atmosphere that are actually very important to us. First is water vapor. Water vapor is water in the form of gas. Please note that it's not steam. The amount of water vapor varies from place to place on Earth, usually ranging from 0 to 4% by volume. Why is it important? Well, it's responsible for clouds and precipitation, and thus the water cycle. There are also tiny solid and liquid particles in our atmosphere called aerosols. These include particles of dust, smoke, salt, and pollen. These tiny particles act as a surface upon which water vapor can condense and form clouds. Without them, we wouldn't have weather, nor would we have the water cycle. Finally, we have ozone. It's a form of oxygen made up of 3 oxygen atoms. For the most part, ozone is concentrated, as we said earlier, in the stratosphere, and that's a good thing because it protects us from harmful ultraviolet radiation. However, sometimes it can form near the ground, and when this happens, it's actually harmful to human beings as it causes respiratory problems. We'll talk more about bad ozone later in this semester when we talk about air pollution. All right, well, that's the end of this video. If you have any questions, please be sure to contact us. And thanks for watching. We'll see you soon.